Wallet, I think, is a little bit incorrect because the word wallet means money, but it's really not just about money, right? A wallet is like your entire interface to this big decentralized ecosystem that has all kinds of applications on it, right? And at the beginning, maybe 5 years ago or 10 years ago, wallets were like fairly simple, fairly automated pieces of software, right? A wallet, you would just store your key. If you want to do something, you would click, and then the wallet would have you type in a password. It would have you approve, and it would be pretty basic. Today, wallets are becoming more and more sophisticated, right? So what's happening with wallets today is you're starting to have things like, for example, MetaMask has an anti-scam feature, right? They have a list of different of addresses that MetaMask knows are connected to scams, and if you try to access them, then it gives you a big warning. There's another wallet called Ravi that has a built-in transaction simulation feature, so when you are signing a transaction, it actually shows you these are the effects that the transaction is going to have, and if the transaction looks dangerous, then it shows you more warnings. Right, so wallets are becoming more and more complex pieces of software that are really not just being these kind of completely neutral gateways to just let the user do what they want, but to try to actively inform the user, actively protect the user, actively kind of be this layer in between the user and the applications that's there to be this more sophisticated actor that actually looks out for the user and protects their interests. Today, this is all done with simple algorithms. I expect over the next 5 years, this will be done with AI as well. So that's the value of AIs as an interface to the game. So third category is AIs as the rules of the game, right? So this is where I think we start getting into some of these kind of deeper and more challenging applications of AI. Basically, imagine using an AI as an oracle to give final judgments about some kind of complex question about the outside world, right? So, for example, you could have a price oracle, right? And you could imagine an AI that searches the internet and actually tries to determine what some particular price is. Another good example of this is in the WorldCoin project, right? So the WorldCoin project is trying to give people one world ID to every unique person. And if you have a world ID, then you can get some quantity of world coins every 2 weeks. And the way that you sign up for WorldCoin is by scanning the orb, right? So who here has a world ID? Okay, a few people. That's good. Now, in order to tell who actually is a person and who is fake, right? In order to kind of tell the difference between a person scanning and making a deep fake of a person and printing out a picture and then trying to scan with the picture, they have pretty sophisticated AI algorithms inside, right? Right now, this is all kind of fully trusted. You have to trust them to have AI algorithms where those AI algorithms cannot be exploited by random attackers and cannot be exploited by the team, right? So right now there's a lot of trust in the system. And I think there's an interesting question of can we use cryptography to try to reduce the amount of trust, right? Can we try to use cryptography to try to actually make AIs that are more secure and that are closer to being trust-free in the same way that other kinds of programs are? So the big problem here is adversarial attacks, right? Two kinds of adversarial attacks. They can come from the inside and they can come from the outside. So in the traditional world, generally you worry about outside attacks and you solve outside attacks by just hiding everything, right? The less you know, the harder it is to attack. But in the crypto space, I think when we believe in decentralization, we believe in making systems secure against the inside as well, right? And making systems secure against inside attacks is, I think, really worth doing, but it is also more challenging. So, adversarial attacks. Here are some two interesting examples of this out in the real world, right? So on the left here, you have a picture of a cat. On the right, you have a picture of a cat. But if you ask a particular AI, the AI will tell you it is very convinced that the picture on the right is a dog. Why? Right? Basically, what you can do is you can train an attack where you can identify very tiny changes that you can make to the cat on the left that will trick the AI and make it think that the cat with a few very small changes is actually a dog. Basically, it's like optical illusions, but optical illusions for robots. The problem is, if you can see the inside of an AI model, and if you basically, the more you know about an AI model, the easier it is to train extremely effective attacks. Now, what we have on the right here is basically adversarial attacks that take the form of a face mask that you can wear. Right? Basically, what they did here is they took an AI for facial recognition, and